Hello guys, this is Faradj from International Tatyurkalta University, Kyrgyzstan. Do you ever have that moment where you step back and think about how something you use every day actually works? More specifically, have you ever wondered how the heck computers actually communicate wirelessly? Well, that's exactly the question we are going to be answering in today's video, because we are going to talk about Wi-Fi. What is Wi-Fi? First, let's cover some of the basics. Wi-Fi stands for wireless fidelity, and it is the same thing as saying WLAN, which stands for wireless local area network. Wi-Fi works with the same principle as other wireless devices. It uses radio frequencies to send signals between devices. The radio frequencies are completely different, say, from car radios, cell phones and weather radios. For example, your car stereo receives frequencies in kHz and MHz range, AM and FM stations, and Wi-Fi transmits and receives data in the gigahertz range. To break it down even further, Hertz is just a unit of frequency. Let's say you are standing on the pier watching waves come in. As you look down at the waves, you can see the crest of each wave rolling by. If you counted how many seconds between each wave crest, that would be the frequency of the waves. So, if the time between each crest was 1 second, that would mean the wave frequency was 1 Hz or 1 cycle per second. Comparing megahertz and gigahertz, these waves are moving at 1 million and 1 billion cycles per second in the ear. And to receive the information found in these waves, your radio receiver needs to be set to receive waves of a certain frequency. For Wi-Fi, this frequency happens to be 2.4 GHz and 5 GHz. These waves are very similar to the frequency found in your microwave. Your microwave uses 2.450 GHz to heat up the food, and your router uses 2.412 GHz to 2.472 GHz to transmit your data over Wi-Fi. This is why some people with old and faulty microwaves experience a problem with their Wi-Fi signal when they try to make popcorn. Just to clear up a popular misconception, these waves are non-ionizing radiation. That means that they do not cause cancer. That's right, kids, microwaves will not make you radioactive. But whether you're in 2 and 4 GHz range or in 5 GHz range, there will be a set of channels your router will communicate on. These channels are slightly different frequency from one another, and they allow multiple routers to communicate in the same area without causing a lot of traffic. Just picture yourself driving on the freeway. If there was only one lane, it would cause a traffic jam. But with multiple lanes, traffic works smoothly. You have probably noticed that you don't have to worry about thinning channels or anything when connecting to Wi-Fi. That's because these usually set up automatically when you connect to your router. Your computer and router will work out the details between them. Just for your reference, 2.4 GHz has around 12 channels, and 5 GHz has around 30 channels. I say around because the number of channels is dictated by the country. So now, you know the radio waves can fly through the ear and pass through a lot of things on their way to your router and wireless device. These waves are also high in frequency, which allow them to carry a lot more data than most other radio frequencies. The high speed and high capacity is what allows you to watch your favorite YouTube videos on your smartphone or laptop while being several rooms away from your router. But the real magic of Wi-Fi has to do with the processing that happens on the end of your Wi-Fi chip. Each device Wi-Fi chip converts zeros and ones into radio waves to be sent out onto their destination, while at the same time converting a steady stream of zeros and ones into data that your device can interpret as a mail, web page or anything else that you do on the web. Thank you for your attention.